Welcome to part 2 of the lesson on section 3.9, related rates. Today we'll examine some related rates problems that involve multivariable functions. We'll use proportional reasoning and substitution to convert them to single variable functions. We're starting with example 3 because the numbering for these examples is continued from the numbering in part 1 of this lesson. Find the rate of change in the angle of elevation of the camera shown below at 10 seconds after liftoff. We're also given that s equals 50t squared, and in the diagram, the horizontal distance from the camera to the shuttle is 2,000 feet. When we assign variables, rate of change in the angle of elevation is d theta dt. We want to find this t at t equals 10 seconds. Our equation should relate the angle to the distances in the diagram. The tangent of theta is equal to s over 2,000. Looking ahead to the implicit differentiation step, I can see that a ds dt is going to appear in this equation. We don't have a number to substitute for ds dt. In order to avoid having that, I can substitute 50t squared from the given information in place of s. That gives us the tangent of theta equals 50t squared over 2,000. Now, taking the derivative of both sides, we get secant squared theta d theta dt equals 50 over 2,000 times 2t. Next, we need to substitute. Since s equals 50t squared, then s is 5,000 when t is 10. Let's use the right triangle to find a value to substitute for theta. By the Pythagorean theorem, the hypotenuse equals the square root of 5,000 squared plus 2,000 squared. We don't really need to find theta. Instead, we can use the triangle to find a value for secant theta. Using right triangle trig, secant theta is equal to the ratio of the adjacent side to the hypotenuse, or 2,000 over what we just found for h. Substituting for secant theta and t, and then solving for d. Moving on to example 4. At a sand and gravel plant, sand is falling off a conveyor belt and onto a conical pile at the rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when it is 15 feet high? So the 10 is change in volume over change in time, dv dt. Diameter is 3 times the height, and we need to find dh dt at the instant when h is 15. We're dealing with volume of a cone, so our equation can be v equals 1/3 pi r squared h. Here's a case in which the volume is a multivariable function. It depends on both the radius and the height. Let's use geometric proportions to express the volume in terms of a single variable. It makes the most sense to rewrite the volume in terms of h, since we need to eventually find dh dt. We need to convert the r in the equation to h's. We know that d equals 3h, and the diameter equals twice the radius, so 2r equals 3h. Solving for that, we get r equals 3/2 h. Substitute this into our volume equation, and differentiate. This concludes part 2 of our lesson on section 3.9, related rates.